Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In the series of lectures related to fundamentals of mechanical engineering and mechatronics, the subject which is in first year with the code of BME 101201. Today I am trying to cover the topic elastic constants and specifically the relation between different elastic constants which are there in the strength of material. The first unit, second part of the first unit is related to strength of material, okay, which is also known as mechanics of material. So, what we do in mechanics? In mechanics, we study the behavior of force or the effect of force on any body. If the body is rigid, then the effect of force will be the change in state, it means the change in position. But if the body is deformable, then in that case we consider that as a strength of material. So, how the deformable body is behaving in the presence of, in the application of different forces. So, the study of strength of material often refers the various methods of calculating the stresses. When the stress will be developed? Whenever a body resists change, when the body resists deformation, then it offers the stress, okay, then it offers the stress. So, the relation between stress and strain is studied in strength of material that I already covered in my previous lectures related to strength of material, okay. So, I am not going in much detail. Another relation which is also important before moving towards the elastic constant, that is the Hooke's law. What basically the Hooke's law is? Within the elastic limit, it is the relation between stress and strain, but the limits are specified here. So, within the elastic limit, the meaning of elastic limit must be clear, we all are knowing. It means the stress in the body which is under the application of force is not exceeding the elastic limit. It means the material or the body will recover its actual shape and size after removal of deforming force. This is what the meaning of elastic limit. So, within that limit, the stress is directly proportional to strain. The stress is directly proportional to strain. So, if I denote the stress by sigma generally and by epsilon I denote the strain, okay. So, sigma is directly proportional to stress is directly proportional to strain. So, that is, and the relation is linear, directly related. So, the curve within the elastic limit between stress and strain will be a straight line. Whenever we are removing the proportionality sign, a constant comes in picture, that is what known as elastic constant. So, today our interest area is this elastic constant, okay, this elastic constant E. Now, so what is there? Only one type of elastic constant is there, or there are many? Yes, there are many as per the application of force, as per the plane on which the force or the stress is induced. On that basis we can classify the elastic constants, we can categorize the elastic constant, okay. So, first one, that is the modulus of elasticity, second one, that is the modulus of rigidity, and third one, that is the modulus, bulk modulus, okay. So, in previous video also I covered these three elastic constants, but in very brief again I am discussing this modulus of elasticity. So, whenever if I draw a body, okay, suppose this is a rectangular bar, it can be a round bar also, it can be of any shape, okay. A force P is there which is causing the deformation, which will cause the elongation, okay. So, the stress on any plane, how it will be? It will be a normal stress, it will be a normal stress, either the force is tensile or the force is compressive. Force इस plane पर कैसा होगा? Normal. it will be perpendicular to the plane. Which plane? This transverse plane. So this rectangular bar is made up of infinite number of these transverse plane. So this force is perpendicular, this stress is perpendicular to the transverse plane. And which type of strain will be there? Obviously there is a possibility of change in length. Okay, either the length will increase or decrease. If it is a tensile, then there is a possibility of increase in length. If it is a compressive force, then there is a possibility of compression, decrease in length. So that is what known as longitudinal strain. Okay, so the relation between normal stress and longitudinal strain within the elastic limit, it is specified as what? It is specified as E, Young's modulus or modulus of elasticity. So it must be very clear, if I am talking about Young's modulus or modulus of elasticity, then we are relating two terms, stress and strain, and specifically the stress is normal stress and strain is longitudinal strain. Okay, another thing which can be here. So, okay, now I am coming to the second type of application. There is a body. Okay, if the body is subjected to some tangential force, the force which is parallel to the plane, what it will cause? Which type of deformation it will cause? It will be causing the shear deformation. The shape of body will change. Shape of body will change. Okay. Okay, so this is the deformation, angular deformation will be there. So this strain phi is known as shear strain, and the stress because of the tangential force which is parallel to the plane is known as shear stress. So if I am establishing the relation, if I am taking the ratio between shear stress and shear strain within the elastic limit, then it is known as modulus of rigidity, which is denoted by G. It is denoted by E, modulus of elasticity. Modulus of rigidity is denoted by what? G. Somewhere you can find it C also. So it is the ratio of shear stress to shear strain. और modulus of elasticity किसका ratio था? Normal stress upon longitudinal strain. Now I am coming to the third one, that is the bulk modulus. Bulk, the term which is very common to everyone now. Bulk means we are talking about the volume. We are talking about the volume. So now just take example with the diagram. Okay, I am drawing a simple diagram, then I am explaining it. Okay, this is a simple cube. It can be a cuboid. It is subjected to what? Equal and like stresses on all its faces. It is written also identical normal stresses. Identical normal stresses से मतलब equal in magnitude and equal in similar in nature. So if equal and like stresses, so all the stresses sigma 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 on all the planes, and all these stresses are normal perpendicular to the plane on which these are induced, and their nature is also tensile. So what will happen to this? This will cause the change in volume. These can be compressive also. So in this case we can observe the volume is increasing. In other case, if the stresses, normal stresses are compressive, then the volume will decrease, volume may decrease. So when a body is subjected to identical normal stresses on three mutually perpendicular directions, the body undergoes uniform change in three directions without any distortion in shape. And the ratio of volume to original volume has been defined as volumetric strain. Obviously, strain is change in dimension upon original dimension. So here I can say delta V upon V, change in volume upon original volume, that is volumetric strain. And bulk modulus, again it is the elastic constant, it is the ratio of stress upon strain. Stress कैसा है इस केस में? Stress is normal. So normal stress is on all the plane. Strain, which type of strain is developed? Volumetric strain. So the relation or the ratio of normal stress to volumetric strain, that is what known as bulk modulus. So, written also. I hope all the three constants are now clear to us. Okay. Now, I am coming to the relation between various elastic constants. Okay. So, first I am going to establish the relation between modulus of elasticity and modulus of rigidity. It means I am trying to establish the relation between E and G. Okay, I am trying to. So, I am considering a square element, or I can say a cube element if I am talking in the 3 dimension, okay, which is subject, sides iski kya hai? Sides are A, the one side is, and it is subjected to Q shear stress on face A, B, C, D, that is the element. So, A, E, C, D. Okay, now because of this shear, what we are observing earlier, the element is A, B, C, D. Because of the application of shear stress Q, which is the shear stress, so obviously the shape of the element will change. It will suffer shear strain, and the shear strain phi is induced in it, and because of this shear strain, what we are observing? We are observing that now the shape is A, D, C dash E. Okay, so this is written also there. Consider a square element ABCD of side A subjected to pure shear as shown in figure AEC dash D. Shown is the deformed shape of the body due to the shear Q. Due to the shear deformation of this, diagonal planes will suffer normal stresses. What I am saying here, I am saying that if a body is subjected to shear, now this is the deformation. So, here we can observe that these diagonal plane, if this is the diagonal plane, earlier it is in this position, now it is in this position. So, it has been subjected to normal stress, What I induced? Earlier kya tha? Stress kaisa tha? Shear stress. But shear stress, because of the shear stress, what I am observing that the diagonal plane which earlier was BD, now it is ED. It means it is elongated. It means it is subjected to normal stress. So, due to shear deformation, diagonal planes will be subjected to normal stresses equal to shear stress. ये हम second year में इस चीज की बात करते हैं, या third year में we talk about this particular thing, कि this shear will be equal to the normal stresses induced on the diagonal planes. So, again I am reading out, so due to the shear deformation, here we will keep this thing in mind, due to shear deformation, diagonal planes will be subjected to normal stresses equal to the shear stress Q, causing elongation of BD, here we are observing also, and compression of AC. Now, AC, earlier it is AC, now it is AC dash. So, one diagonal plane is increasing in length, one diagonal plane is decreasing in length. It means what we are observing, or what we can suggest, that the diagonal plane BD per normal stress tha, because of this it is now ED, and on the diagonal plane AC it is also subjected to normal stress. That's why its length is compressed. Okay, now how to find out the relation between E and G? So, for that particular purpose, okay, drop a perpendicular BF to a diagonal DE. From point B, drop a perpendicular on diagonal DE, which is the deformed diagonal, okay, and phi is the shear strain and G is the modulus of rigidity. Strain in diagonal BD, earlier the diagonal BD था, ठीक है ना. So, strain कितना हो गया? D minus DF upon DF. Why I am taking BD and DF equal? Because this deformation, this shear strain is not so much कि BD or DF both are almost similar. Okay. So, DE minus DF upon DF. DE minus DF is equal to EF, and DF, what can I write? That I can write DB, and DB equals to what? In this square element, I can write DB equal to AB root 2. Yes, square element में diagonal का size root 2 into the side, and EF. For finding out the EF, what I can consider? For finding out EF, I can consider this BE cos 45, almost this angle is equal to 45. So this angle is also equal to 45. So EF in this triangle BEF, I can say EF equal to BE cos 45, BE cos 45. So I am writing what? EF equal to BE cos 45, and B, what can I write? BE. For BE, what can I write? A tan phi. From which? From this. A, B, E. If this is the phi strain, then what can I write? B, A tan phi. So by simplifying this, what I am getting? I am getting A is cancelled. So A tan phi cos 45 1 by root 2. So tan phi upon 2. So tan phi, if phi is not a very large angle, then I can say tan phi is almost equal to phi. So this becomes phi upon 2, phi upon 2, and phi equals to, what can I write? Q upon G. Phi equals to, so this becomes Q upon 2G. It is clear up to this point. Again I am repeating, drop a perpendicular drop करने के बाद I am trying to find out the strain. So this is the first. Now this is because of the what? This is because of the shear strain. Now because of the normal stresses, one plane, if this plane is subjected to normal stress, then its length will increase. If this plane is compressed, if I say I have to increase the length of this, then I can elongate this in this manner, normal stresses. Another way of elongating it, I can compress it, then also it will be elongated. So on that basis, so we know that the pure shear gives rise to the axial tensile stresses. I already discussed this term, okay, in the diagonal direction of dB, and axial compression Q at the right angle. Because of this, the strain in diagonal B, strain in diagonal dB, it will be equal to what? It will be equal to Q upon E minus, this is now because of the compressive stress, this is equal to mu Q upon E. Okay, so what it will be? It will be this equation, Q upon E plus mu Q upon E. What can I write now? Q upon E 1 plus mu. So this is also the strain in diagonal dB. Earlier also I had already established the relation for finding out the strain in diagonal dB, which is equal to Q upon 2G. Okay, Q upon 2G. So this is the equation 1, this is the equation 2. If I am equating both the equations, Q upon 2G equals to Q upon E 1 plus mu. So what relation I am getting? I am getting the relation E equals to 2G into 1 plus mu. What is mu here? The mu is, what is mu here? Mu is Poisson's ratio. Poisson's ratio, what it is? Mu, it is the ratio of lateral strain upon longitudinal strain. Okay, so Q upon E, it is because of the compressive stress Q, strain किस डायरेक्शन में कंसीडर कर रहा हूं? I am considering the strain in the perpendicular direction, so that will be the lateral direction for it. So Q upon E into Poisson's ratio, so that is coming out Q upon E plus mu Q upon E. So this is the relation between E and G. So if any confusion, any doubt is there, okay, I don't think there is anything related to that. All points are clear, E and this. Another relation which we can establish here between what? E and K. Another relation between E and K. But before moving to the relation between E and K, one important term which I already explained here also, but from this diagram it will be more clear to us, the generalized Hooke's law. I am not going in the much detail of the generalized Hooke's law, but I am talking about the strain. Okay, suppose an element is subjected to stresses in all directions, sigma x, sigma y, sigma z in the x, y, z direction, and epsilon x, epsilon y, epsilon z is the strains in x, y, z direction respectively. So if I have to find out the strain in x direction, okay, strain in x direction because of sigma x will be sigma x upon E. Very good, nothing new there. Okay, this is the relation between the because of the Hooke's law. But the strain in x direction will also be because of sigma y and sigma z. So how we can get sigma y upon E, that is the strain in y direction. If I multiply it with Poisson's ratio, then it becomes the strain in x direction. Similarly, sigma z upon E, that is the strain in z direction. If I have to get the strain in x direction, then multiply this with the Poisson's ratio, because Poisson's ratio is what? It is the lateral strain upon longitudinal strain. So what it is coming out, if I have to find out the strain in lateral direction, means in the perpendicular direction, then longitudinal strain को किससे multiply करना होगा? Poisson's ratio से. So the same thing we are doing here also. So sigma x upon E, that is the longitudinal strain in x direction because of sigma x, sigma y upon E, that is the longitudinal strain in y direction because of sigma y. But when I multiply this quantity with Poisson's ratio, it becomes the lateral strain. Lateral, किसके lateral? Y के, and these direction can be x or z. Here I am considering x. So sigma x upon E minus Poisson's ratio into sigma y upon E minus Poisson's ratio into sigma z upon E. Minus क्यों आ रहा है? Because if lateral dimension is increasing, longitudinal will be decreasing. If longitudinal is increasing, lateral will be decreasing. Okay, so that we can observe. If length बढ़ रही है, तो width या thickness घटेगी. That is the simple. So similarly, epsilon x, epsilon y, epsilon z. Why I have discussed this? Because here also हमने उसको use किया है, and in the next relation also I am going to use this. Okay, so the relation between modulus of elasticity, it means E and K. E and K. चलिए E और K के बीच में relation देख लेते हैं. Now suppose this is subjected, this is a stress element which is subjected to equal and like stresses. Equal and like stresses क्यों कह रहा हूँ? Because I am talking about the volumetric change. Okay, so equal and like stresses P on all its faces. So Ex, it means what? The strain in x direction. So what can I write as per the generalized Hooke's law? I can write P upon E minus mu into P upon E minus mu into P upon E. P upon E क्या है? The strain in, the longitudinal strain in x direction. What is P upon E? That is the strain in y direction. When I am multiplying this with Poisson's ratio mu, it becomes the strain in either x direction or in z direction. So similarly, Ex, the strain in x direction, I can write P upon E minus Poisson's ratio into P upon E minus Poisson's ratio into P upon E. So it becomes P upon E into 1 minus 2 mu. Okay. Similarly, I can find out the strain in y direction and similarly strain in z direction. Strain in x direction, strain in y direction, strain in z direction. If I sum up, then it becomes the volumetric strain Ex, Ey and Ez. So it becomes what? If I am summing up all these, so 3P upon E 1 minus 2 mu, that is the volumetric strain. As per the definition of bulk modulus is what? Bulk modulus is the ratio of normal stress and volumetric strain. So ratio of P upon EB, so P upon this. Now this is the relation between what? This is the relation between E and K. So now I am available with both the relation. One is the relation between E and G. It means modulus of elasticity and shear modulus. And this is the relation between modulus of elasticity and bulk modulus. कई बार question आ जाता है कि establish the relation between E, K and G. So what will you do? I will be doing what? Mu को यहाँ से निकाल के, mu को इस equation से निकाल के I will be comparing. So I will be getting the relation between E, K and G. So that's what I am doing with here. So by eliminating mu between the above two equations, we can get the relationship between E, G and K. So from both the equation, I am finding out the mu and comparing it. And comparing it, the simple mathematics you can perform here by performing the simple mathematics that is available here on your screen. By doing this, you can establish the relation between E, K and G. So this is what all about the relation between elastic constant. So first of all, we must be very clear about elastic constant. Elastic constant, modulus of elasticity क्या है, bulk modulus क्या है, modulus of rigidity क्या है, इनको हम define कर पाएं and किस condition में किस type का stress and किस type की strain की बात कर रहे हैं. That is the one thing. Then the second thing, relation between E and G and relation between E and K, दोनों में हम relation establish करें. So both the relations already discussed. But if the question is establish the relation between all these three, कई बार स्टूडेंट क्या करता है, he or she uses these equations and directly writing. No, in that case you are supposed to establish the relation between E and G first, E and K first, then establish the relation between E, K and G by comparing the mu, Poisson's ratio, and find out the desired result, E equal to 9 kg upon G plus 3K. So I hope now by viewing this video you will be having no doubt related to different elastic constants and how to establish the relation between various elastic constants. Thank you very much. Keep watching. Thank you.